Here are 30 most commonly asked scenario-based AWS Glue interview questions, along with detailed and informative answers. 1. Scenario: your organization has a large dataset stored in Amazon S3, and you need to perform ETL extract, transform, load operations using AWS Glue. How would you design an AWS Glue job to efficiently process and transform the data? Answer: I will create an AWS Glue job, defining a crawler to discover and catalog the S3 data. Then, I design a transformation script using Apache Spark and AWS Glue to perform necessary data manipulations. To optimize performance, I'd leverage Glue's dynamic frame capabilities, enabling schema evolution and handling complex nested structures efficiently. The job would be orchestrated to run on a scheduled basis or triggered by an event, ensuring the timely processing of the dataset. 2. Scenario: your team is dealing with semi-structured data in JSON format stored in Amazon S3. How would you utilize AWS Glue to extract meaningful insights from this data, considering nested structures and varying schema? Answer: I will design an AWS Glue crawler to catalog the JSON data, allowing Glue to infer the schema. Leveraging Glue's dynamic frames, I would handle nested structures, allowing for flexible schema evolution. The transformation script would then use Spark functions to extract insights from the data, and the resulting transformed data could be stored in a target destination or queried using AWS, Athena, or other analytics tools. 3. Scenario: your organization is migrating from an on-premises data warehouse to Amazon Redshift. How would you use AWS Glue to facilitate this migration, ensuring minimal downtime and optimal data transformation? Answer: I will create an AWS Glue job to connect to the on-premises data warehouse, extract the data, and transform it according to the target Redshift schema. AWS Glue can be used to parallelize the ETL process, optimizing performance. Once transformed, the data can be loaded into Amazon Redshift using the Glue connection to Redshift. The migration process can be orchestrated to minimize downtime, and AWS Glue can be integrated with AWS SCT Schema Conversion Tool for comprehensive schema migration. 4. Scenario: your team is dealing with sensitive data, and you need to implement data masking during the ETL process using AWS Glue. How would you design a Glue job to ensure that sensitive information is appropriately masked before loading it into a target data store? Answer: I will incorporate data masking techniques within the transformation script of the AWS Glue job. Leveraging Glue's dynamic frame capabilities, I can apply masking functions to specific columns containing sensitive information. This ensures that the data is appropriately masked before being loaded into the target data store, maintaining data privacy and compliance. 5. Scenario: your organization is dealing with a large volume of streaming data, and you want to use AWS Glue to process and analyze this data in real time. How would you design a solution using AWS Glue to handle streaming data efficiently? Answer: I will use AWS Glue, streaming extractors and transformers to handle streaming data efficiently. This involves defining Glue streaming jobs that can continuously process and transform the incoming stream. Leveraging Glue's dynamic frames and Spark streaming capabilities, I can apply real-time transformations on the streaming data. The results can be stored in a destination such as Amazon S3, or analyzed in real time using services like Amazon Kinesis Analytics. 6. Scenario: your organization is using AWS Glue for ETL processes, and you want to implement version control for your Glue scripts. How would you manage versioning for AWS Glue jobs and ensure reproducibility of ETL processes? Answer: I will use a version control system such as Git to manage the Glue scripts. Each Glue script and associated artifacts would be versioned, ensuring reproducibility of ETL processes. AWS Glue itself does not provide native version control, so using an external version control system is essential. Additionally, documenting changes in the version control system can aid in tracking modifications and maintaining an audit trail. 7. Scenario: your organization is using AWS Glue for ETL processes, and you need to perform complex data cleansing and enrichment tasks. How would you leverage AWS Glue transformations to achieve this, considering various data quality issues? Answer: I will design the AWS Glue transformation script to include custom logic for data cleansing and enrichment. Glue's dynamic frames can be used to apply transformations such as filtering out invalid records, handling missing values, and enriching data with additional information. The script would be crafted to address specific data quality issues, ensuring that the resulting dataset meets the desired quality standards. 8. Scenario: your team is working on a project that involves aggregating and summarizing data from multiple Amazon Dynamod tables. How would you use AWS Glue to create a consolidated view of the data, considering the NoSQL nature of Dynamod and the need for aggregations? Answer: I will use an AWS Glue crawler to catalog the Dynamod tables, and then design a transformation script using Apache Spark and Glue to aggregate and summarize the data. Glue's dynamic frames can handle the schema-less nature of Dynamod, and Spark functions can be used to perform aggregations. The resulting consolidated data can be stored in a target location or queried using services like AWS Athena for further analysis. 9. Scenario: your organization is using AWS Glue for ETL processes, and you want to optimize the performance of your Glue jobs. How would you tune and optimize AWS Glue transformations to achieve better performance? Answer: I will consider several optimization techniques for AWS Glue jobs. A. Partitioning and bucketing. Utilize partitioning and bucketing in Amazon S3 for better data organization and query performance. B. Data compression. Choose appropriate compression formats to minimize storage costs and enhance query performance. C. Data types. Use efficient data types to reduce storage requirements and improve processing speed. D. Dynamic frame transformations. Leverage Glue's dynamic frame transformations efficiently to avoid unnecessary data shuffling and optimize Spark transformations. E. Parallelization. Adjust the degree of parallelization based on the available resources and the nature of the transformation tasks. F. Regular monitoring and analysis of Glue job metrics can help identify bottlenecks, and optimizations can be fine-tuned accordingly. 10. Scenario: your team is dealing with a diverse set of data sources, including on-premises databases and cloud-based data stores. How would you use AWS Glue to create a unified data catalog that spans across these various sources? Answer: I will design AWS Glue crawlers to connect to each data source, whether on-premises or in the cloud, and catalog the metadata. By creating a centralized AWS Glue data catalog, the data from these diverse sources can be unified. This allows for a consistent view of the data landscape, enabling efficient discovery and querying of data regardless of its origin. 11. Scenario: your organization is adopting a serverless architecture on AWS, and you want to leverage AWS Glue for ETL processes. How would you design serverless ETL workflows using AWS Glue and other serverless services in the AWS ecosystem? Answer: I will design an AWS Glue workflow that triggers ETL jobs based on events or schedules. By utilizing AWS Lambda functions, I can orchestrate the Glue jobs, allowing for serverless execution. Additionally, services like Amazon EventBridge or Amazon Step functions can be incorporated to enhance the serverless orchestration of the entire ETL workflow. This architecture ensures that ETL processes can scale dynamically based on demand, without the need for managing infrastructure. 12. Scenario: your organization has adopted a microservices architecture, and you want to implement real-time data synchronization between microservices using AWS Glue. How would you design a solution to keep data consistent and up to date across multiple microservices? Answer: I will use AWS Glue streaming capabilities to create streaming jobs that continuously process and synchronize data between microservices. Leveraging Glue's dynamic frames and Spark streaming, the streaming jobs would capture changes in real time and update the corresponding microservices. This ensures data consistency across microservices, without the need for batch processing, enabling near real-time synchronization. 13. Scenario: your organization is using AWS Glue for ETL processes, and you want to ensure data lineage and traceability. How would you implement data lineage tracking using AWS Glue, considering complex transformations and multiple data sources? Answer: I will leverage AWS Glue's native support for tracking data lineage. By using AWS Glue crawlers to catalog metadata and capturing transformations and Glue jobs, the data lineage is automatically recorded in the AWS Glue data catalog. This enables traceability from source to destination, providing a clear understanding of how data flows through the ETL processes. Additionally, external metadata management tools can be integrated for more comprehensive lineage tracking. 14. Scenario: your team is dealing with a high volume of data updates in Amazon S3, and you want to use AWS Glue to efficiently process incremental updates without reprocessing the entire dataset. How would you design an ETL solution that handles incremental updates? Answer: I will design AWS Glue jobs to use incremental extraction and processing techniques. This involves identifying new or updated data since the last processing run using timestamps or unique identifiers. By comparing this information during the transformation phase, only the changed or new data is processed. This approach minimizes the processing time and resources required, making the ETL process more efficient. 15. Scenario: your organization is dealing with data stored in multiple Amazon RDS databases, each with a different schema. How would you use AWS Glue to perform schema evolution and harmonize the data for unified analysis and reporting? Answer: I will design AWS Glue jobs to handle schema evolution using Glue's dynamic frames capabilities. The Glue transformation script would be crafted to dynamically adapt to the varying schemas of different RDS databases. By leveraging Spark functions, the script can harmonize the data, ensuring a consistent structure suitable for unified analysis and reporting. The resulting transformed data can be stored in a target location or queried using analytics tools. 16. Scenario: your team is dealing with a diverse set of data formats, including Avro, Parquet, and CSV, stored in Amazon S3. How would you use AWS Glue to create a consolidated data lake that allows for efficient querying and analysis across these formats? Answer: I will design an AWS Glue crawler to catalog the diverse set of data formats in Amazon S3, allowing Glue to infer the schema for each format. Subsequently, AWS Glue jobs would be created to transform and consolidate the data into a unified format, such as Parquet, optimizing for efficient querying. By leveraging Glue's dynamic frames, the transformation script can handle the nuances of each format, providing a consolidated and optimized data lake for analysis. 17. Scenario: your team is dealing with a high-throughput data stream from Amazon Kinesis, and you want to use AWS Glue to process and analyze the streaming data. How would you design an ETL solution using Glue to handle real-time data transformations on the streaming data? Answer: I will design AWS Glue streaming jobs to process and transform the streaming data from Amazon Kinesis in real time. By leveraging Glue's dynamic frames and Spark streaming capabilities, the transformation script can apply real-time transformations to the incoming stream. The results can be stored in a target destination or analyzed in real time using services like AWS Athena or Amazon Redshift. This approach ensures that streaming data is processed and transformed as it arrives, enabling real-time analytics. A team scenario. Your organization is using AWS Glue for ETL processes, and you want to implement custom data cleansing rules based on business logic. How would you design a Glue job to accommodate custom data cleansing logic for specific columns or records? Answer: I will design the AWS Glue transformation script to include custom data cleansing logic based on business rules. By using Glue's dynamic frames, I can apply specific transformations to individual columns or records as needed. This allows for the implementation of custom data cleansing rules within the Glue job, ensuring that the data meets the specific requirements of the business. 19. Scenario. Your organization is adopting a multi-cloud strategy, and you want to use AWS Glue to perform ETL processes on data stored in Google Cloud Storage. How would you design an AWS Glue job to efficiently process and transform data residing in a different cloud storage environment? Answer: I will design the AWS Glue job to connect to Google Cloud Storage by defining appropriate connection settings. AWS Glue supports external data sources, and the transformation script would be crafted to handle data residing in a different cloud storage environment. The job would use Glue's dynamic frames to process and transform the data efficiently, allowing for seamless ETL operations across multi-cloud environments. 20. Scenario. Your organization is using AWS Glue for ETL processes, and you want to implement error handling and retry mechanisms for failed Glue jobs. How would you design a robust solution to handle errors and retries effectively? Answer: I will implement error handling and retries in AWS Glue jobs by incorporating the following practices. A. Logging. Implement comprehensive logging within Glue jobs to capture errors and relevant details. B. Error handling logic. Use try-catch blocks in the transformation script to handle exceptions gracefully. C. AWS CloudWatch alarms. Set up CloudWatch alarms to monitor Glue job metrics and trigger alerts in case of failures. D. AWS step functions. Integrate Glue jobs with AWS step functions to define retry logic and error handling workflows. By combining these practices, a robust solution can be implemented to handle errors and retries effectively in AWS Glue jobs. 21. Scenario. Your team is dealing with a large dataset in Amazon S3, and you want to use AWS Glue to perform data deduplication based on specific criteria. How would you design a Glue job to identify and eliminate duplicate records from the dataset efficiently? Answer: I will design the AWS Glue job to perform data deduplication by implementing the following steps. A. Crawling. Use an AWS Glue crawler to catalog the dataset in Amazon S3, allowing Glue to infer the schema. B. Transformation script. Design the Glue transformation script to identify duplicate records based on specific criteria, such as unique keys. C. Dynamic frames. Utilize Glue's dynamic frames to efficiently handle duplicate detection and elimination, ensuring optimal performance. By implementing these steps, the Glue job can efficiently identify and eliminate duplicate records from the dataset. 22. Scenario. Your organization is using AWS Glue for ETL processes, and you want to implement data quality checks to ensure the accuracy of transformed data. How would you design a solution using AWS Glue to perform data quality validations and handle discrepancies effectively? Answer: I will integrate data quality checks into the AWS Glue transformation script to ensure the accuracy and integrity of the transformed data. This involves implementing validation logic within the script, such as checking for null values, verifying data ranges, or validating against predefined business rules. AWS Glue's dynamic frames can be leveraged to efficiently handle these checks. Additionally, it would implement logging mechanisms to capture discrepancies and anomalies, enabling proactive identification and resolution of data quality issues. 23. Scenario: your team is dealing with sensitive data, and you want to encrypt the data during the ETL process using AWS Glue. How would you design a Glue job to handle data encryption, ensuring the security and privacy of sensitive information? To address the security concerns associated with sensitive data during the ETL process, I would design the AWS Glue job with the focus on data encryption. This involves implementing encryption measures at different levels. Firstly, I would leverage AWS Key Management Service KMS to ensure data at rest in Amazon S3 is encrypted. Secondly, for data in transit, secure connections between Glue jobs and data sources or destinations would be configured to encrypt data during transmission. Lastly, within the Glue transformation script, field-level encryption functions would be implemented specifically for sensitive fields, ensuring that the data is encrypted before being loaded into the target data store. This comprehensive encryption strategy safeguards the security and privacy of sensitive information throughout the entire ETL process. 24. Scenario: your organization is adopting a data lake architecture using Amazon S3, and you want to use AWS Glue to organize and manage metadata efficiently. How would you design a solution to leverage AWS Glue for metadata management in a data lake environment? In the context of a data lake architecture on Amazon S3, efficient metadata management using AWS Glue involves a systematic approach. Initially, I would employ AWS Glue crawlers to discover and catalog metadata from diverse data sources stored in Amazon S3, covering various file formats and structures. To enhance the metadata catalog, would incorporate custom annotations, tags, or labels providing additional context and information about the data. AWS Glue's built-in capabilities for tracking data lineage would be leveraged to understand the relationships between different datasets and transformations. Furthermore, integration with AWS Lake Formation would be implemented to enforce fine-grained access controls and manage permissions on the data lake. This holistic design ensures that AWS Glue becomes an effective tool for metadata management, promoting better organization, discovery, and governance of data within the data lake environment. 25. Scenario: your organization is using AWS Glue for ETL processes, and you want to implement a data retention policy to automatically delete outdated data from the target data store. How would you design a Glue job to handle data retention effectively? Answer: for implementing an efficient data retention policy using AWS Glue, I would structure the Glue job to handle this process seamlessly. The first step would involve defining the retention criteria, specifying how outdated data is identified based on timestamps or other relevant parameters. Subsequently, within the Glue transformation script, logic would be incorporated to flag or mark data that meets the criteria for deletion. Additionally, AWS Glue's dynamic frames capabilities would be utilized to handle the data efficiently. Finally, the job would be orchestrated to run on a scheduled basis, triggering the removal of outdated data from the target data store. This approach ensures that the data retention policy is automated, reducing manual intervention and promoting a systematic approach to data management within the AWS Glue environment. 26. Scenario: your team is working on a project that involves joining and aggregating data from multiple Amazon Dynamod tables. How would you use AWS Glue to create a consolidated view of the data, considering the NoSQL nature of Dynamod and the need for aggregations? In the scenario where data needs to be consolidated from multiple Amazon Dynamod tables, AWS Glue would play a pivotal role in streamlining this process. Firstly, I would employ AWS glue crawlers to catalog the metadata of the Dynamod tables, allowing Glue to understand the schema-less nature of NoSQL data, subsequently edging the dynamic frames capabilities in AWS Glue. I would design a transformation script to join and aggregate the data as per the project requirements. This script would utilize Apache Spark functions to handle the specific challenges presented by the NoSQL nature of Dynamod, ensuring that aggregations are carried out effectively. The consolidated data can then be stored in a target location or queried using services like AWS Athena for further analysis. For more interview questions like this scenario-based AWS Glue interview questions, please check Part 2. I have provided a link in the description below for Part 2 of this series.